Hello, Professor Rad here, and today we're going to talk about the division algorithm. You might have heard this before in the past as long division, so that's what we're going to look at. You might also want to take a moment to pause the video and copy down these steps of the division algorithm. I'm going to talk about these and then we'll do a few different examples of using it. So the division algorithm is a way of finding a quotient and a remainder, and you complete the following steps to do so. First, we're going to divide the first few digits of the dividend, the number you're dividing into, by the divisor, the number you divided by. I forgot a parentheses here. Then you're going to multiply your answer by the divisor and write your answer underneath the numbers you divided into. Then we'll do a subtraction and a bringing down. And step 5 is to repeat those steps. So in summary, we do a divide, a times, a subtract, bring down. Divide, times, subtract, bring down. Divide, times, subtract, bring down. This is going to be our process as we go to do the long division algorithm. So let's go ahead and do an example. Okay. So for example 22, we're going to divide 13,581 by 27. And I've written a little note to myself of the steps of the division algorithm. Divide, multiply, subtract, bring down. This is what we're going to keep repeating as we go through this process. I'm going to start out by doing the 13,581. And that's going to go inside the division box. And then the 27 is going to go on the outside. Okay, so when I go to start, I'm going to start from the leftmost digit, which is weird because normally we start on the right, but we're going to start with the leftmost digit this time. And we're going to keep moving over until we get to a number bigger than the divisor. In other words, if I start with 1, I'm not bigger than 27. So I move over and now I have 13. Still not bigger than 27. So now I move over and I have 135. I'm finally bigger than 27. So the question we're going to ask ourselves is, what is 135 divided by 27? I don't know. So we can use any one of our techniques to help us figure out 135 divided by 27. I'm going to use repeated subtraction. So I'm going to start out with 135, and I'm going to subtract 27. So carry, borrow here, we've got an 8. Okay, 108, still bigger than 27, so let's subtract that again. Still bigger, so we can subtract again. 54, still big enough. So that's a 4 and a 14. That gets me 7. Ooh, 27 is 0. Cool. So 135 divided by 27 is 1, 2, 3, 4, 5. So since I was looking at 135, I needed to go out to that 5. I'm going to put the 5 over there. Next, that was my dividing. Next, I need to do a times. The numbers I'm going to multiply are this 5 up here times this 27. So you multiply what you just wrote by the number out on the side. So 27 times 5. That's a 10, 11, 12, 13. It's 135. So since 27 times 5 is 135, I write that right underneath here. And then my third step is a subtraction. So I'm going to subtract. 135 minus 135 is 0. And then we bring down the next number. And that is one iteration or one round of the division algorithm. You keep going until you can't bring anything down anymore. So since we're able to bring down the 8, we have to keep going. Now we get kind of a weird situation here because 27 can't go into 8 because 8 is too small. When this happens, when you're trying to go into a number that's smaller than you are, right? So let's say I have 27 friends and only 8 cookies. If I want everyone to have the same amount, I can't give out any cookies because only 8 people would get a cookie. So when that happens, we're going to put a 0 here. This is because 0 times 27 is 0, and 8 minus 0 is 8. So the answer to the going in question was 0. The multiplying, 0 times 27 is 0. And then the subtract, 8 minus 0 is 8. Now we have to bring down the 1. And here we have 81. 81 is definitely bigger than 27, so we can go ahead and do the division here. And I'm going to use repeated subtraction again. So over on my scrap paper here, I'm going to do 81 and repeatedly subtract 27. So that's once, twice, 3 times a lady. Okay, so we subtracted 27 3 times. So I'm going to put a 3 up here. And since we didn't get any remainder, we actually know that 3 times 27 is 81. If you're not sure, 3 times 7 is 21, so I would carry the 2, write down the 1. 3 times 2 is 6, plus 2 is 8, so I would get that 8. I'm going to subtract and get 0, and now there's nothing left to bring down. So 13,581 divided by 27 is going to be 503. So there we have it. We did one iteration of the division algorithm, or one example using it. Now, maybe you noticed some patterns as we went through and did this. For example, maybe you noticed that when we did our subtraction here, we had an 81 and we had to subtract 27 1, 2, 3 times. So you might have been able to do a shortcut and not write this part at all. Something else you might notice is that, well, since we're dividing by 27 each time, maybe it would be more helpful to have a multiplication table for 27 than to always have to do this subtraction. So that's a technique I'm going to use in the next example. For this problem, we're going to use the division algorithm again as well, and we're going to divide 8,413 by 11. And what I'm going to do here, this is what most students who have difficulty with division tell me helps them the best. So this is a technique I usually recommend. I'm going to create a multiplication table for 11. And I'm going to start with 0, oddly enough. So I'm going to do 11 times 0, 11 times 1, and I'm going to go up until 9. So 2, 3, 4, 5, 6, 7, 8, 9. And I know anything times 0 is 0, and anything times 1 is itself. And then remember, we can get the next product by adding 11. So 11 plus 11 is 22. If I add 11 again, I get 33, 44, 55, 66, 77, 88, and 99. What this does when we create a multiplication table like this, it helps us to not have to think so much during the divide and times parts of the long division algorithm. So instead we can focus on the overarching process and not on the little steps in between. So in fact, let me write a little reminder. We do a dividing question, a multiplying, a subtract, and a bring down. And for the last part of our setup here, we're going to take 8413 and put it in the box. And then what you divide by is going to go on the outside. So this is my setup for dividing in this manner. So I'm still going to follow the long division algorithm, but I made kind of like this little cheat sheet off to the side here. We're going to start out with 11 going into 8. So 8 is smaller than 11, so we're not big enough yet. And now we have, if I move over 1, 84. So 84 is definitely bigger than 11. So I'm going to go to my cheat sheet here, and I look for the closest to 84 without going over. That looks like this one here. 88 goes over 84, so I want the closest without going over. That means I have a 7, and 11 times 7 is 77. This 7 is the answer to the dividing question. So I'm going to put it over the 4 since we looked at 84. And the 77 is the answer to the times question. So I'm going to put that underneath. Now I can do my subtract and then a bring down. So I'm going to subtract 84 minus 77, I think is 7. And I bring down the next digit. And now I repeat this process. So I'm looking at this number now, the 71, and I want to find the closest on my list to 71 without going over. In this case, it looks like it's going to be 66 because 77 is bigger than 71. So 66 is the closest without going over, and to get there, we will need to do 11 times 6. So 6 is what I put up top, and 66 is what I'm going to subtract. I get 5, and then I will bring down the 3. Okay, last time, because there won't be anything to bring down after this, I'm going to look in my table for the closest to 53. So closest to 53 without going over is this 44. So I'm going to put the 4 on top, and the 44 is what I subtract. 4 here, and that will be a 9. So at the end here, we had nothing left to subtract, or to bring down, sorry, after we did our subtracting, we had nothing left to bring down. This answer is smaller than 11, so we know that we're done. And so our answer is 764 as the quotient with a remainder of 9. So I can write my final answer, 8,413 divided by 11 is 764 with a remainder of 9. And like I said, students often tell me that having this multiplication table helps them. So it's part of the setup to a division question, creating your multiplication table. And then you look in the right-hand side for the closest thing that doesn't go over. And it tells you the answer to both the dividing question and the multiplying question. So here are a few problems for you to try out on your own, see how you do. We've got 12,617 divided by 31, 1,162 divided by 28, and 36,466 divided by 7. In our next video, we're going to see how our calculators can help us out to help us find quotients and remainders, because your calculator is set up to be either a fraction or decimal answer, not quotient and remainder. So we'll see how we can hack our calculator to do that. Oh, but you know what? There's one more thing I meant to talk about in this video that I was worried I would forget about, and I nearly did. So I wanted to talk about a connection to algebra. So I have an example here. It's an algebra question. Again, I'm not going to ever ask you to do anything like this, so don't wig out about it. But notice it has a very familiar shape to that long division process we just looked at. So what I did was I took this thing and I asked a dividing question and got 4x cubed as the result. I did a multiplying process to get this number here. Then I did a subtraction and a bring down. So this division algorithm we use for numbers is the same as the division algorithm you're going to use for polynomials in an algebra class. I also wanted to point out this process of algorithms. So computers think and process in terms of algorithms. They think in terms of generalized descriptions of what to do, as opposed to specific things of what to do. Here's what I mean by that. In this problem that we did before, a specific question to ask would be, how many times does 11 go into 84? That's a specific question with specific numbers, 11 into 84. A generalized question would be, how many times does the divisor go into the first few digits of the dividend? That's a generalized phrase where I'm not using specific numbers, but more just descriptors of things in general. And that's how computers think. So if you're interested in computer programming, you have to think in terms of generalized objects in broad descriptions and be able to describe processes in terms of those general things. So you'd have to be able to say, divide the divisor into the first few digits of the dividend, multiply that divisor by the quotient and subtract that product, and then bring down any remaining digits of the dividend. Then repeat this, right? That's how you would tell a computer how to do something. So big idea behind an algorithm is you are taking this larger problem of division and breaking it up into smaller tasks, and you can focus on those smaller tasks to work through. Okay, now this time we're done. In the next video, we're going to see how our calculator can help us do some long division. Bye for now, and I will see you then.